Okay, we're going to go into division, but before we do that, I just want to see if you can find a pattern when we multiply conjugates together. So these binomials are conjugates, something you might have learned, probably should have been exposed to in an earlier algebra class. Conjugates, a plus bi and a minus bi are conjugates. So 3 plus 2i and 3 minus 2i are conjugates. Negative 5 plus I, negative 5 minus I, conjugates. Eight minus 2i, 8 plus 2i. Those are conjugates. So looks like the same binomial, but one is subtraction, one is addition. What happens when we multiply conjugates together? When we multiply conjugates together, the outer and the inner cancel out. The outer and the inner will cancel out. Once again, the outer and the inner cancel out. So that leaves us with just the first and the last. So the first is 9. A positive times a negative is subtraction. And then 2i times 2i is 4i squared. I squared is negative 1. So we have negative 4 times negative 1 is positive 4. And we get a complex number that only has a real part, so it becomes a real number. Let's multiply these conjugates. Negative 5 plus I, negative 5 minus I, those are conjugates, so the outer and the inner will cancel out. The first is 25. The last is negative I squared, which is negative 1. So 25 minus negative 1 is 26. And this last one, 8 times 8 is 64. Because these are conjugates, the outer and the inner cancel out. We can go right to the last. A negative times a positive is a negative. 2i squared is 4i squared, which becomes 64 plus 4, which is 68. So the rule is a plus bi times a minus bi. Let's see if we can figure this out. Negative abi, positive abi, those cancel out. So we're left with a squared. A positive times a negative is a negative. B squared, I squared. And I squared is negative 1. So we'll have a squared plus b squared. So when I take a complex number, multiply it by its conjugate, we get a squared plus b squared. Now this is important because where we're going with this is division. And when you divide, so when dividing, multiply the denominator and the numerator by the conjugate of the denominator. So when dividing, you're going to multiply both the denominator and the numerator by the conjugate. That's going to make this denominator real. So we want to make the denominator real. And you can achieve that by multiplying by its conjugate. But if we multiply the denominator by the conjugate, we have to also multiply the numerator, so that we're really multiplying by a factor of 1 and not changing the value, we're just changing what it looks like. So in the numerator we have 13 times 5 plus 12i, and in the denominator we have 5 squared plus 12 squared. So 13 times 5 is 65. 13 times 12, 13 times 12 is 156. So 156i all over 25 plus 144. 25 plus 144 is 169. $13 does go into all of those numbers, so I've got 65 over 169 plus 156i over 169. We're going to divide by 13, which gives us 5 over 13 plus divide by 13, 12 over 13i. Hopefully you got that. 5 over 13 plus 12 over 13i. Gonna move it right there so that you can see it. Okay, so let's try another one. 6 minus I over 1 plus I. 6 minus I over 1 plus I. In fact, let's do this as a try, and I'll come back in the next video and I'll give you the answer.